Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Suhaib bin Halimi. So I will explain how to use Pspice software for part A, which is I choose series RLC circuit. So how we want to construct series RLC circuit in this Pspice software is, first we need to place all these component here. We have capacitor, resistor, inductor, switch, voltage source, and also ground. So how we want to place all these component here, we need to click this option and the library will pop up. Then we just type the component we want. For example, resistor, we just need to type R and then click enter, and the component will show here, and then we just need to place it. And then repeat the same step for others component. Next, how we want to connect this component here, we need to draw the wire just by clicking this option and just connect the wire using this pencil. So I will show the example. And click this option, draw wire, and just connect the component. So next step is we want to put the value for each component. How we want to put the value is we just double click on that particular component and we change the value here. Just click this value option and change the value. Then we save the value, then click OK. Then the others, the step applied to the other components also, for the resistor, inductor, and so on. Next, since this question required us to observe the current response, we need to put the current probe. So how we want to put the current probe is we click this option and this probe will appear here. Then we just put into the circuit and on the voltage display and current display. Next, we need to adjust the setup analysis on this tension mode and adjust this tension here. And we just need to adjust the print step and final step. So in this particular simulation, I will use print step 1 millisecond. Final step is 10 millisecond. Then we click OK and we close. So how we want to observe the graph is we just need click this simulation option. Then the graph will appear like this. So that's all for part A series RLC circuit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Wafi bin Tahir and I'm going to present about the part B, series resonance circuit, and how to simulate this circuit. Okay, firstly we need to construct this circuit by getting all the component right. So firstly we click the get new part, and then for the voltage supply we use VAC, and here the VAC, let's see, we could place it anywhere, VAC component. And then for the capacitor we just write C, we get the capacitor part, and for the inductor we write L, we got inductor, and resistor we write R. And then to change the value of this component, we double click here and we can change the value based on the lab sheet, which is sin omega t for the VAC. And same with the capacitor, we just double click and we can change the value based on the lab sheet, and the inductor is the same and resistor is the same also. So for the waveform simulation, firstly we need to put the probe current at the capacitor, inductor and resistor, as we want to get the current waveform of this capacitor, inductor and resistor. Then for the simulation, we want a frequency response graph. So we use AC sweep, where for the start frequency we put it 1k and in frequency we put it 10k. So our graph will appear from 1k to 10k, 10 kilohertz. Then for the simulation, we click the simulate button icon here, and then the simulation waveform graph will appear here. So we will need to find the frequency response in the half power frequency from this graph, from the frequency response graphic. Then to get the coordinate for the frequency response, which is the peak frequency here, we click the toggle cursor and we choose the peak cursor, and we mark the coordinate here to get the coordinate to appear on the graph here, like this. Then we get the resonant frequency value, which is 5.68k, and for the power frequency, we click the cursor slope, and here is the one of the power frequency, and the other one is here. This is the other one. So we will get the resonant frequency value, the half power frequency value. Okay, from this value we could get the quality factor value from the resonant frequency, and we could get the bandwidth value from the half power frequency, which is 1.2 f1 f2 minus f1. So for bandwidth, from the bandwidth we could calculate the quality factor by dividing with the resonant frequency dividing with the bandwidth. Okay.
Assalamualaikum, my name is Fauzi. Today I will explain about the Pspice schematic simulation. For part C, I choose a parallel case 1, which is parallel of resistor and capacitor. So to find the component, we pick the get new part icon. So we write resistor is R, V sign, and capacitor in this get new part to find this capacitor and V sign. So for setting V sign is we set DC equal to 0, V off equal to 0, V amplitude is V peak, which is 339.41 volt. This value we get for the 240 VRMS multiplied by SERT2. So RMS convert to V peak is multiplied by SERT2, and frequency is 50 as stated in the lab sheet. So save attribute and OK. So resistor is 240 ohm. To set it, we just write 240 in this value part. And capacitor is 13.26. We set it at the value micro. So 13.26 micro is we converting the XC to the C value. So 1 over 2 pi fxc. So we get the 13.26 micro. So also we place a ground in the circuit. For the probe, to find the total current, we place the current probe around this part, and voltage across this part, because in parallel voltage will be equal. For the current resistor, we place it at the front leg of the resistor, and the capacitor is at the also in the front of the capacitor. So after setting, we set a setup analysis on the transition, and then point step is 0 nanosecond, final time is 0.1. This is the transition setup is for the output analysis or the graph. So after that, we click simulate. So as we can see, we can get this sinusoidal wave. So the blue one is the voltage sinusoid. So to differentiate this voltage and the current sinusoidal, we need to add plot to the window, and then we trace all the current to divide the current and the voltage. So we pick IC1, IR1 and IV1, and then we delete the current, so we can get a current graph and the voltage graph. So to label the graph, we pick the toggle cursor and then select the color that you want, or the current load that you want. So in this case, I want to pick a capacitor current. So choose a cursor pick and then click mark label. So we can get a value of the current, which is 1.45 amp for the capacitor current. Also the same for the resistor current, you can get 1.4007, and the total current. Also we can drag this label to make sure that we can see the value properly. So for the total current, we get 2.0164 amp. That's the same for the voltage. If we pick, we add the label and pick the cursor peak, we can get a 336.18 volt. Then we can compare the simulation and the calculation. So after settle with the labeling, so to print the graph, actually there are two kind of printing. First we click file, and then we click print, or we can click window or copy to clipboard. If we use both type. That's all for me. Thank you.